This is the world's biggest RC ground effect plane.
The largest RC plane I have ever made, and one that has taken me many months of planning and building, all to see whether it would actually float above the ground using the ground effect. I've always had a dream to build my own version of the world's largest full-size ground effect aircraft, the Caspian Sea Monster, which was a giant Soviet aeroplane that flew on a cushion of air just above the surface. These ground effect vehicles were incredible machines, weighing hundreds of tons and flying up to 300 miles an hour just 20 foot from the sea to evade radar. I've made a couple of model ground effect vehicles before, but recently I decided it was time to take on a real challenge, to build a remote control acranoplan ground effect plane that would be bigger than any others I'd ever seen. But as you might imagine, there were a lot of steps to this project. And the first step was to get to grips with understanding what the ground effect actually is. As you might already know, ground effect is a term that refers to high pressure air under the wings of a plane. As aeroplanes come into land, they actually experience a cushioning effect as air becomes trapped and compressed between the wings and the ground. Back when this was discovered, it got a few engineers thinking about the idea to build an aircraft that only flies in ground effect, never going higher than a few meters off the ground, as this would be a lot more efficient than flying up high. So the next step was how to design the world's largest RC ground effect plane. I came up with a rough format for the full-size aircraft, deciding on a 6-meter long fuselage and 2.6-meter wingspan, similar to the ratio of the Caspian Sea Monster, and then started work on building a quarter-scale prototype out of foam board. This model could be used to find any flaws in the design and improve them before committing to the full-size model. I'd covered the model in silver aluminium foil tape to help with waterproofing. However, I was finding it a little inconvenient on this sunny day.
Gosh, so reflective.
You look up for a second.
This model was powered by two 50mm electric ducted fans, as I thought these would probably be a good alternative to high-power jet engines. How well would it fly though? The plane was flying in ground effect, but not flying that well. Adjusting the centre of gravity balance helped through shifting batteries further forward, but the plane needed to fly at quite an aggressive angle of attack, more than I'd anticipated, and it kept flying out of ground effect.
Oh my god!
As you can see, this made it quite difficult to control. Some slight adjustments were needed. So I took the plane back to the building board and cut away some of the fuselage so I could raise the leading edge of the wing. This meant that the whole wing was now at more of an angle, allowing it to scoop up more air. Doing this would also increase the PAR effect from the fans. The fans being at an angle aimed below the wing would now compress more air, and this effect is called power augmented ram. Now with a few stickers as decoration, it was time to see if this single change of increasing the wing angle would lead to improved performance. Thankfully, it did. The plane was now able to fly much closer to the ground at a proper angle, and I could really feel that bubble of air beneath the wing. It was flying much more stably, and was able to stay at more of a constant height above the ground. One issue I found though was that the plane was influenced by the wind more than I'd expected, and this was especially apparent on the final test run of the day, when something a little strange happened.
3, 2, 1, throttle up. Oh, what the heck was that? What the heck was that?
What happened there?
I have no idea what just happened. What on earth happened there? It just like flicked up.
Yeah.
I wonder if a gust of wind caught it through that gate over there. We're gonna have to investigate that, I think.
After some investigation, watching back the footage, I realised that this wind was probably caused by a bonfire that had just been lit in the next field, causing some sort of small tornado to appear. A very strange occurrence, to say the least.
Oh, I thought it was going to be less damage. Oh, then at least the nose is all right. It's just destroyed the all of this. All of this is fine. The tail needs rebuilding, but that was always going to be a bit of a problem.
We might have just discovered that gusty conditions would be quite dangerous for this project. The plane had been damaged by that gust of wind and needed repairing before the next phase of the project, which was the water test. We had the aerodynamics of our ground effect plane pretty much nailed, so now it was time to turn attention to the hydrodynamics. It was all well and good having a decent flying ground effect plane, but if it couldn't take off from the water, it wouldn't exactly be fulfilling our mission of building a true seafaring ground effect plane, just like those from the Cold War. But you might ask, how will this plane take off from the water? And that's a very good question. Some seaplanes use specially shaped floats to take off from the water, and these floats have steps to detach the water and reduce drag. Some larger seaplanes use specially shaped hulls as effectively giant floats to lift them entirely out of the water as they move forwards. As the water passes over the step, it detaches and the plane can take off. So I made sure to build a couple of steps into our ground effect prototype, and I hope that these would be just at the right places to get the plane to lift off from the water cleanly. Would they work though? Well, of course, we'd only find out with this thing on the water.
Right, ready? 3, 2, 1. Okay.
The first hops into the air seemed to show that the steps were working, but I discovered another problem.
Oh no! Oh, I think it might be a bit tail heavy.
The plane was flipping into the air. Why was this when the plane had been perfectly balanced over the ground? Well, it turned out there was quite an innocent explanation.
Ah, Emma, I've noticed something. The elevator's going backwards.
I'd forgotten to double check the direction of the controls. As I tried to pitch forwards, the plane would do the opposite and flip backwards. This is why you should always do pre-flight checks. With that problem quickly rectified, I could now see that the plane was performing excellently, skimming across the surface until it could lift off gracefully into the air and cruise on that cushion. The only thing I had to worry about was a slightly leaky fuselage and a lack of range, meaning that the plane became stranded a couple of times in the middle of the lake. Thankfully, we'd come prepared with a rescue boat.
Oh, God. No! How does RC test flight do this all the time? Right, Thunderbird 2 to the rescue.
We'd learnt a lot from these tests. The steps were in the right place and the design seemed to be a winner. Now all we had to do was scale this thing up, which sounds simple, but as I'd quickly find out, building the world's largest RC ground effect plane wouldn't be as easy as I'd hoped. So the first job was selecting what we would make the airframe out of. I decided on 2cm insulation board, which is lightweight and quite rigid. I laid down a bunch of sheets and drew the shape of the fuselage on with a pen. Next I could cut the shapes out using a large bladed craft knife and a metal ruler to keep everything nice and straight. The shapes were then glued and taped together with reinforced packaging tape for extra strength. Now to properly glue everything together, and soon we had a strong box that would become the base of the project. I had lots of help from my assistant Emma, and everything at this stage came together very quickly. The fuselage was done, so now it was time to move it to the large assembly area of the workshop and start thinking about the wings, which would need to be very strong. As you can imagine, with such a large and heavy model aircraft, making strong wings was critical for this project to be a success. I'd need to use some carbon fibre, and with this I got all of the carbon for this build sponsored by Easy Composites, so a big thank you to them for this. I also got sent a bunch of XPS foam to make the main body of the wings. But how on earth were we going to turn these big foam blocks into sleek aerodynamic lifting surfaces?
I almost dropped it.
Well, thankfully I'd planned ahead, and a few weeks earlier I'd asked Emma to build a homemade CNC machine to help cut the wings from these foam blocks. And after a lot of work and many hours of tweaking and fine-tuning, Emma finally had a fully computer-controlled hot wire cutter that could cut wing profiles at the press of a button.
What's the bottom look like?
Oh,
Oh, perfect.
oh.
Perfect.
The way this worked was really quite simple. Firstly, a 0.4mm nichrome wire is heated using a power supply, providing 29 volts at 2.5 amps directly to the wire. This is attached to 2 towers which move independently using 2 motors each. The towers can move and draw different shapes, effectively meaning that you can program it to cut straight or tapered wing shapes by drawing 2 different airfoils at either end.
Oh, look at that! That's come out very nicely, actually. Yeah, that looks very good. And how straight is it? Oh, it looks dead straight. I can't see any bowing in that. Not really.
Got a little
Awesome.
wiggle on here, but this is where it goes slower.
Well, there's no wiggle I can see on here.
Do you know it here?
Yeah, but it's imperceivable.
Once cut, the part can be removed from the rest of the foam and voila, you have a wing. This machine was seriously helpful in producing custom parts for this project, but if you're looking for custom parts to be manufactured for your own projects, you might want to try ordering components from PCBWay, who are sponsoring this video with a quick ad.
I've used PCBWay for all sorts of projects over the years, large and small, and I think they're absolutely fantastic. From sheet metal parts for my Guinness World Record-breaking RC car to machined aluminium rocket engine test stands, it's all been very helpful.
PCBWay offers several services: PCB prototyping, 3D printing, CNC, sheet metal fabrication, injection molding, and OEM. All you need to do is upload a part and they will make it for you. Once you've ordered, a couple of weeks later, it will show up at your door.
Whatever you make, PCBWay can probably help, so make sure to check out the link in the description to take you to their website. Thank you very much to PCBWay for sponsoring this video.
The wing of the aeroplane was going to be far too big to cut on one sheet of XPS foam, so we decided instead to just cut the front and rear edges using a sheet of lighter insulation board in between. The carbon rods were passed through the fuselage at strong mounting points and then glued inside the insulation board. With the leading and trailing hot wire cut edges glued into place, the plane was now looking more like a plane. But I did have a pretty major concern. Would the wings actually be strong enough?
The wings are flexing a bit, so from the front they're drooping, and that's not really what we want.
If the wings flexed, the ground effect wouldn't be as strong, as the ends of the wings would allow air to leak out, lessening the strength of the cushion and reducing lift. Instead, the difficult decision was made to go with another solution. We first reinforced the wing using more insulation foam board, and then next started to cover the entire airframe in lightweight fiberglass. This would hopefully make the plane much more rigid overall and the wings a bit stronger. This seemed like a good solution, as it would also make the plane a lot more watertight. But the problem was this: fiberglassing would of course make the ground effect plane heavier, adding around 6 kilograms to the total flying mass. The plane was already going to be super heavy, so hopefully this extra weight wouldn't eat into the flying performance that much.
Well, that's the first bit of fiberglassing done. It's the hottest day of the year currently, so not ideal conditions, but we've just about got the fuselage top all done. And tomorrow we're going to focus on the wings.
Over several days, almost every inch of the airframe was covered in fiberglass, until it was one huge, very strong hull. Now it was time to turn attention to the tail, and like everything on this build, this took quite a lot of engineering to get right.
It's just like a real aeroplane at this stage.
The problem was that this tail needed to be a T-tail to keep it away from the turbulent air of the wing to do its job of stabilising the aircraft. The problem was that T-tails are quite difficult to build, as they tend to not be very strong without lots of heavy reinforcement. Thankfully, we came up with a pretty good design in the end that used lots more Easy Composites carbon. While Emma worked on finishing off the mounting system, I turned attention to the electronics. How would we power this gigantic monster of an RC plane? Would I be able to provide it with enough power to get up in the air? I bought 4 42 size electric outrunners and installed them on a strong carbon tube with some custom made 3D printed parts. With some 13x6 master airscrew propellers, the total thrust from these motors should be around 10 kilograms or around 100 newtons. That was quite a lot of thrust, but the plane was expected to weigh over 20 kilograms, so would they have enough thrust to propel the entire aircraft into ground effect? We'd only find out on the first test flight. With servos installed and control surfaces hooked up, the plane was nearing completion, and it was all getting quite exciting. We just needed to check everything worked and then go for our first mission of getting this plane flying over the ground in the ProjectAir test field.
Let's go.
After weeks of work and a whole lot of problem solving, would the world's largest RC Ekranoplan finally fly? It was time for action.
Right, test day is here. We've got the plane all finished and it's now ready for the maiden flight. The weather is quite breezy, so we're going to do our best to get it over to the test field in one piece. So there'll be just about enough space there to see what this thing can do and yeah, see if we can get it to get into the air in ground effect. This is the largest aeroplane I've ever built. It's also the heaviest aeroplane I've ever built. With this wind as well, it's a big unknown.
Unfortunately, we quickly realised the wind was getting worse. We'd already waited a few days for some good weather to come around, but knowing what had happened to the scale test model when it got into turbulent air, I wasn't too keen on trying to fly this one in similar conditions. The difficult decision was made to scrub the mission and wait a few more days. Sometimes the difficult decisions are the right ones though. After about a week of patiently waiting, suddenly the weather looked perfect for an evening test at the flying field. At short notice, I assembled a small team of friends who were able to help and brought the giant aircraft out of the workshop once again, this time fully ready to see if it could take off and fly in ground effect.
The wind's perfect this evening. We've waited until it's all died down. A couple of willing volunteers over here who are going to be helping with undertaking this mission.
I was going to say it's not that heavy, but I'm not carrying that.
It's quite heavy from my side.
The plane was very heavy and far bigger than I was used to.
Tessa, you make sure that doesn't roll too much.
Even getting the aircraft into the field was a big challenge, taking careful planning and the use of our heads, quite literally in the case of Debbie.
Woo! High five. High five. Nice. Yeah.
The plane looked magnificent and spirits were high, but I was definitely a little nervous. This was the largest flying machine I'd ever built, and one that was extremely experimental. I knew that the scale model had worked, but this was a whole other beast. My main concern was, would there be enough power, and would the wings provide enough lift? It was time to finally find out.
This is the plan. First of all, power up the motors and see if the thing can just lift itself into the air a little bit. Then we'll take it from there and see if we can fly across the whole field.
This next step would be the most important so far. If the plane didn't have enough power or if the wings didn't work, we'd probably have to go right back to the drawing board.
Okay. Motors armed, powering up. Looks promising. Oh! Yes! It was hovercrafting! That's exactly what we wanted to see.
A strong start, but now for the ultimate test. Would it fly?
World's largest Ekranoplan RC is go. Yes! Look at that! Way! Yes! Oh, that worked so much better than I even thought it was going to. There's so much power there.
The plane had flown, lifting just a few inches off the ground, allowing it to float gracefully along the field.
I'm really glad it worked.
Yeah, same. Just as it was coming down, I was like, oh, it's done it. And then I was like, oh no, keep flying it, keep flying it.
With a quick blast of the throttle, the tail would come up as the air was squeezed out from under the trailing edge of the wing. Airborne, I could now back off the throttle and allow the plane to cruise along, modulating the power to keep the plane at the optimal height. It felt perfect, just as if a giant magnet was keeping the plane airborne just above the surface of the grass. Pulling back on the stick, the plane was able to fly at more of an aggressive angle of attack, and might have climbed a little higher with some more throttle. But in this field, I had to keep it lower down to the ground. What a great feeling! The world's largest RC ground effect plane was working. So, we've got the plane working over the ground, and the next step would be to get it working over the water. But for now, we could celebrate a successful start to a project that had seen us achieve something pretty impressive. This was now the world's largest working RC ground effect aircraft. I think this just shows if you have enough ambition and a few friends to help along the way, big things are possible. Thank you very much for watching this video, the first part of a new series, I hope. Make sure to check out more videos on ProjectAir. Yeah, go and have a watch of the other stuff on there, and yeah, let me know what you think in the comments. Make sure to like this video and subscribe, of course, and I will see you on the very next video. Here's one for you to watch in the meantime while you're waiting for the next video to come out. Thanks for watching, and I'll see you on that one. Bye for now.